PCIe slots, Peripheral Component Interconnect Express, Intermediate Level Introduction. Modern computers need a fast way to connect high-performance components, like GPUs, SSDs, network cards, expansion devices. This is where PCIe, Peripheral Component Interconnect Express, comes in. PCIe slots are found on the motherboard and provide high-speed communication between the CPU and expansion devices. At the intermediate level, understanding PCIe means learning how expansion cards connect to the system, how data is transferred at high speed, what lanes and slot sizes mean, how PCIe affects performance. What is PCIe? PCIe, Peripheral Component Interconnect Express, is a high-speed interface standard used to connect hardware components to the motherboard. In simple terms, PCIe equals high-speed data connection for expansion devices. Example concept. GPU, SSD, means PCIe slot, means high-speed communication with CPU. Why PCIe is important. Older technologies like PCI and AGP were slower and limited. PCIe provides faster data transfer, scalable performance, better efficiency. Example concept. High-speed devices means need fast connection, means PCIe solves it. What is a PCIe slot? A PCIe slot is a connector on the motherboard where expansion cards are installed. Common devices using PCIe: graphics cards, GPU, NVMe SSDs, Wi-Fi cards, sound cards, capture cards. Example concept. Expansion card means inserted into PCIe slot, means connected to system PCIe lanes. Core concept. PCIe uses lanes to transfer data. Each lane consists of one transmit path, one receive path, lane representation. X1, X4, X8, X16 lanes. X1, X4, X8, X16 lanes. Examples: X1 means 1 lane, X4 means 4 lanes, X8 means 8 lanes, X16 means 16 lanes. Key idea: more lanes equals more data transfer capacity. Example concept. More lanes means higher bandwidth, means better performance. PCIe slot sizes. PCIe slots come in different physical sizes. X1, small, X4, X8, X16, largest. A smaller card can fit into a larger slot. Example concept. X1 card means can fit in X16 slot. PCIe bandwidth. Bandwidth depends on number of lanes. PCIe generation. Simplified concept. Bandwidth is proportional to the number of lanes multiplied by the speed per lane. Example. X16 slot means highest bandwidth. X1 slot means lowest bandwidth. PCIe generations. Each PCIe version improves speed. Common generations: PCIe 3.0, PCIe 4.0, PCIe 5.0. Key idea: each generation roughly doubles speed. Example concept. New generation means faster data transfer. How PCIe works. PCIe uses a point-to-point connection. Device: PCIe lane. CPU chipset device. PCIe lane. CPU chipset. Step by step, device sends data. Data travels through PCIe lanes. CPU or chipset receives data. Processing occurs. CPU versus chipset. PCIe lanes. PCIe lanes come from CPU lanes, high speed, used for GPU and NVMe. Chipset lanes used for additional devices, slightly slower due to routing. Example concept. GPU means CPU lanes. USB/storage means chipset lanes. Real-world example. Gaming PC. GPU means PCIe X16. Means CPU SSD. Means PCIe X4. Means fast storage. Wi-Fi card means PCIe X1. PCIe versus other interfaces. Interface speed usage. PCIe very high, GPU SSD. SATA moderate, HDD SSD. USB, external devices, peripherals. Advantages of PCIe. Advantages include very high speed, scalable lanes, efficient communication, flexible device support. Example concept. PCIe means fast and flexible connectivity limitations. Challenges include limited number of lanes, shared bandwidth, chipset lanes, compatibility with older versions. Example concept: too many devices means lane limitation. Concepts learned. What PCIe is, how slots and lanes work, difference between slot sizes, PCIe generations, how PCIe connects devices. Simple definition: PCIe slots, high-speed connectors on the motherboard that allow expansion devices to communicate with the CPU using multiple data lanes. Final summary: PCIe is a critical technology that enables high-speed communication between the CPU and expansion devices like GPUs and SSDs. It uses lanes to transfer data, and more lanes provide higher bandwidth. Different slot sizes and generations determine performance and compatibility. Understanding PCIe is essential for building modern computers and optimizing performance for gaming, storage, and professional workloads.